Sorry, it's just the first time I've ever heard that. What am I supposed to do? So some quick announcements. I know we're a little behind, so I'll go quick. But there is talk of a tournament, a pinball tournament for Attack from Mars in the chill-out room. If you haven't been in the chill-out room, there are space-themed pinball machines for play, and inquire as to the availability for a tournament. If you're interested in Soldering Olympics, that has a hard deadline for round 1. You can still play round 1, but if you want to get into round 2, you need to submit your board before 3 p.m. So do that. Capture the Flag, basically every other contest should be running. Just go to their respective place. If you don't know where that place is, ask me, ask registration, ask literally anybody in the hallway. They'll figure it out, right? Hacker Conference. But other than that, coming up next, we have Joe Rozner with Vibes All the Way Down.
Thank you. I guess Claude can't help us with the projector, unfortunately. So I'm Joe. This is Vibes All the Way Down. Who here has seen Nicholas Carlini's Black Hat LLM talk from Unprompted this year? Anyone? No? All right. Well, I'm assuming that no one's tried to replicate the work. But great, and it's all being new for you. This wasn't the first instance of when I think there was a big shift in terms of vulnerability research from a AI-assisted or dominated sort of like attempt or strategy. But I think it was a big shift in terms of how people were thinking about it and the availability that people saw of these tools as being able to do this type of work. And it really showed the simplistic approach that Anthropic was taking when they were starting to use these tools in this way. So I don't normally do a Who Am I slide because I don't think it usually is important. But I think in this case it actually helps to frame some of the rest of this content. So I've had a multi-decade career in software engineering and security, and I'd consider myself an expert. I think other people do as well in these domains. And up until the last handful of months, I'd say that my opinion of AI was pretty skeptical at best and dismissive at worst. It was a fun toy, and it could help in inconsequential situations where I wanted to do something that I didn't know how to do. But the output generally wasn't very good, and it wasn't good enough or reliable enough for me most of the time. And this was kind of my experience using ChatGPT and the Claude Web interface, the chat consoles basically just didn't get what everyone else was seeing. I hadn't had one of those moments of the excitement that others had, and it was just it just didn't seem that impressive to me. But I saw all these cool things people were doing, and the FOMO sort of set in, and I was like, there has to be something here. I must be missing something. I don't know what's going on. And around March of this year, a friend convinced me that I needed to give Claude Code a try. That I was using tooling wrong, and that was my issue. As soon as I adopted Claude Code, everything would be great, and I'd understand. So I think there's a lot of fear being spread about the impact that these tools will have, not just in vulnerability research, but tech in general, engineering, security, work in general. And I think it's undeniable that these tools have lowered the bar to do some of this work. I think they've enabled people that traditionally couldn't do some of these things to now do them. But I also think that it's massively overhyped. And that a lot of the information coming out of these companies like Anthropic and OpenAI, they've invested a ton of money in these tools, and it is in their interest to sell you tokens and convince you that this is the future. And there's a ton of people now running wild, playing with something they don't really understand, showing off the cool things that they can do. And this isn't intended to sell you anything or make you a believer. I don't frankly care at the end of the day. And I don't work at a company trying to sell you tokens or convince you that this is the path forward. I just want to provide a hopefully less hyped and biased account of my experience doing this, showing you what I was able to do and like what that experience is like. To do that, I'm going to present 2 case studies covering the first 2 targets that I focused on, and give an account of what I've learned, what the process looked like for me. I'm going to jump around a bit because that's kind of what happened and how I approached the problems. And so it's maybe a little convoluted, but I think it will make sense as it goes. So back in 2022, I was doing some vulnerability research on this like corporate spyware app called WorkTime. And this is like an app that basically like tracks your computer usage and reports it back so that like your leadership can see what you're doing and spy on you and see if you're like fucking around and like, I don't know, looking at porn at work or something. And the application was written in PHP, and the installer provided a web server, a PHP interpreter, and this special loader called IonCube. And IonCube is a source code protection tool that's intended to protect PHP, because when you ship PHP, like it's there. You can read the code, and people don't want their IP stolen or finding vulnerabilities. And so this allows you to do that without leaking that in the environment. So the source is encrypted, and it looks something like this. It's this big blob of base64 encoded data, and the loader process, it processes this as it's loaded into the PHP runtime. And so it basically does a bunch of steps to decrypt and decompress and do some other like things, and gets this into effectively what are Zend bytecode, and then executes it. And so you need the loader in order to actually run this code. Otherwise, it doesn't do anything. I was able to find some information about it, but not enough to like understand how to actually like recover the source code. It was something that people had spoke about in the past, but it wasn't like super public about how it all worked. Luckily, I found this like really sketchy service that I could pay 10 euros for 10 days and just decrypt as much as I wanted. And this worked great. I did this, and a friend and I ended up finding like some vulnerabilities in this WorkTime product, and eventually allowed us to do like a password reset and take over arbitrary accounts. And we did this for the admin and like, demonstrated that we could do a whole thing, and it was great. I have since tried to report this. I have gotten no response from the company, and I'm just kind of done. I am not going to release the vulnerability for this because I think their cloud SaaS thing is also vulnerable, and that would be bad. But there are CVEs like that are reserved. They'll probably never get flipped public because the company hasn't responded. At the time, we'd considered reverse engineering the loader and building our own tool, but we ended up not doing that. It just seemed like a lot of work, and we really just wanted to find the bugs. But I am an experienced reverse engineer. I know like quite a bit about PHP internals because I've done some PHP like plugin development, and I've built disassemblers in the past. And so this seemed like it would be a huge project, but like something within my wheelhouse, but it just wasn't like, it wasn't a good enough use of my time, especially when it was so cheap to use one of these services. But fast forward to 2026, and I'm verifying that this chain still works as I'm trying to report this bug. And I start wondering, like I had just started playing with Claude Code, and I'm like, is this the thing that I try to do? Like have it reverse engineer this, build me a decryptor and a decompiler for it. And I was like, yeah, that seems like a good thing. Like, let's see how good it is. So like I said, at the time I was using Claude Code, and this was what everyone was using. Like, I don't know if Codex existed yet, but if it did, it was like the models that Anthropic had were typically seen as better. This is like before the current generation of OpenAI models. And so I started with the Anthropic Pro plan. This is the $20 a month plan that is the cheapest one that you can get and like use Claude Code with. I don't know if you can still use this plan with Claude Code. I think they may have changed it or are going to. You can? Cool. And I believe this was around like the Opus like 4.5 or 4.6 period. It was definitely before the 1 million token context windows. And when I started off, I switched back and forth between Sonnet and Opus without any real methodology, just kind of like, I got to conserve tokens because I don't have a lot. And this was mostly lack of experience and trying to optimize for cost rather than quality, which I have since gone the complete opposite way, and I'll talk about that in a bit. So I'm typically a binary ninja user, and I migrated all my workflow over to that from a plethora of tools in the past. All of this is doable with Ghidra and pretty much any other tool. So you don't need to be a binary ninja user. There's a number of MCP servers that you can get that are plugins for the disassembler. But at the time, skills were all the hype, and everyone was like, MCP is dead. Everything is going to be skills. And so I ended up finding this kind of sketchy, weird project that you just kind of load into Binary Ninja, and it exposes a web server that you can just send commands to, and it executes. So it's basically RCE as a service in your disassembler, and then a tool that you could have a skill for that would go and do some of that stuff for you. And this was this seemed like the easiest way to get started. The prompt I started with was pretty basic and broad. This was all the instruction that I gave the agent, and it went off getting started. Did it cut off or no? Okay, cool. Almost immediately, it started making really good progress, shockingly, and that really surprised me. It started identifying structures of the file and getting to the point where we could start recreating how to do the actual decompression and decoding and reversing the encryption that's in there. It identified PRNG algorithms and encryption algorithms that were being used. And this looks really impressive, and it kind of is impressive. And the thing that I kind of understood is the way that it does this and why it's able to is that a lot of this is based on specific constants that are present in a PRNG or in a compression algorithm, and so it knows all those things. A good reverse engineer who's experienced with those algorithms probably also knows that, but I didn't because I've never worked with any of the random things it was using internally. And so, it was really good at that, and something that, would have taken me probably weeks to figure out, if at all. But without getting too deep into the weeds, it got stuck pretty quickly. The outer layers of encryption, compression, and encoding had been reversed, and I had recovered a bunch of strings that clearly show it was on the right path. But the agent just couldn't figure out how to get access to the bytecode in the file. And that's really what we needed in order to build the decompiler, in order to bring back from the bytecode to actual PHP. It was trying to brute force these XOR shifts and trying to figure out the ciphers and the keys and figuring out how to get it, and it just could not do it. It had re-implemented a bunch of the algorithms in Python, and it wasn't clear whether those algorithms were correctly written or not. And that was kind of a problem. It was are we going in the right path? Are we starting from a bad starting point? And so LLMs have a concept of a context window, which is sort of the model's working memory. There's a fixed amount, and it's measured in tokens. And Anthropic now has million token context windows, but it was smaller when this started. And every prompt and every tool call, thinking, output, they all produce tokens and fill up the context window. And I was doing nothing to manage this at the time. What happens when you run out of context window is that the harness compacts, which basically is a summarization of what's in there, and then it clears out the context window, and then it puts in the prompt, and it restarts. And as you get closer and closer to it being full, the quality of the responses and the work tends to go down. This is called context rot. And so generally there's a lot of people that are focused on managing this better. But the compaction is a pretty slow process. You also pay for the tokens that are being used during that process, and so it becomes kind of expensive if you're just constantly compacting and constantly filling up the context window. And so one of the early optimizations that I made was to build a subagent to do the reverse engineering. And what that does is it spins off a separate agent that has a new context window that inherits from the previous one. It does all that work, and then when it wraps up, it sends back like a response to the primary agent, telling it like what it found. And so presumably, if it's not spending like a long time in that subagent, it's getting like a new subagent each time. Things are coming back. It's not filling up the primary context window. And this did really help. This made compaction happen much less frequently, and it made it much faster to move forward. The other issue that I ran into fairly quickly is that I didn't really have a good mental model of the reverse engineering that happened. It's not easy to follow along, and like the agent is kind of just producing code and like, I don't know, like this looks right, maybe like it looks like something's coming out of it, but like I don't really understand like what's going on or like how any of this stuff works. And so another thing that I found out pretty quickly was like I can just add like document as you go to the prompts. And it started building up documentation of like what it was trying and what it was figuring out and structure and algorithms. And I could go reference that and I could go read that. And it wasn't great, but it did help me follow along. And the other tip a friend gave me was the BTW command, which I don't know if this is only like a Claude thing, but like you can use like the BTW command and ask it a question, and this doesn't go into like the primary context window, and it can't do tool calls and it can't do something. But if you want to like say like, hey, like why are you doing this? Like, what is this thing? Or like, are you stuck? Or why are you stuck? You can do that and get a response, and then you can take an action based on like that. And so that really helped get a better understanding of what was going on. And so I was doing this all on Linux, but I was reverse engineering a DLL because the Windows, like the installation for like work time is for a Windows server, and this limited my ability to do any dynamic analysis. But IonCube also has a Linux loader, so I downloaded it and I switched and like I tried to switch the binary. And one of the things I figured out pretty quickly was that like bn.py was like it was pretty difficult to work with like multiple files back and forth, and I didn't have a really easy way to like, do this. And so I had the agent like redo all the analysis and like make sure that things like made sense still and they mapped across, but all the addresses were different. And it had a really hard time and started getting confused, and it was trying to reference addresses that didn't exist, and it was not going well. The docs got really messy. And it got really, really confused. And I mentioned dynamic analysis. And one of the things that I wanted to figure out was whether or not the reconstructed algorithms that the agent wrote were implemented correctly. And there had been some bugs already, and they had been fixed. And like it kept going back and forth, and I wasn't sure if like the fixes were correct or not. And so I was really trying to get it to use C types to just like call into the shared object and like send values in and like make sure the data coming out was the same in both. And I just couldn't get it to do that. So after about a week of this being stuck, I decided to move on. I wanted to pick up a new project with a different scope and maybe come back to this in a little bit. Like this seemed like I didn't have like a clear path forward. I wanted to build some tooling, but I didn't want to build it right now. But I could come back to this and try something else. So a number of years ago, Travis gave me one of these good tag boards. And effectively, it's like a credit card-sized programmable NFC tag. And I was playing around with it like a few years ago, and something I noticed was that reading it with a flipper would cause the flipper to crash. And I did some debugging on the flipper, and I discovered that it was a heap overflow, but I never got to determining whether or not it was exploitable before it had been fixed upstream. But I had this dream of like finding a bug in the Flipper Zero firmware that could lead to remote code execution from an NFC tag or like the sub-gigahertz radio or whatever, one of those like remote sort of like protocols that you could use, and like build a payload that would just like wipe the flipper, kind of like the iHunt pineapples that Wesley and Magru did at DEF CON like years ago. So I started off more or less the same, still using Claude, but I had upgraded to the Max 20 plan because I kept burning through all my tokens and having to wait hours, and I was like, this is not it. I cannot do this. And I was like, I'll do a month or two of the $200 a month plan, and then I'll downgrade. But I just want to get this done so I can actually see. So I started off with another relatively simple prompt. But giving it specific instructions to focus on the wireless protocols, because I didn't want it to find bugs in the UART or other things that I couldn't reach in a meaningful way. And I found a number of potential vulnerabilities, but nothing that seemed immediately easy to trigger. Another thought was taking a look at some of the other forks of the firmware, given that many people use them for additional functionality. If I could find a vulnerability that was present in all of them, I could build a single exploit that would affect as many as possible. So I had the agent take a look at the Unleashed firmware and do a full analysis of it for vulnerabilities that compare which ones were present in just one or in both. And one of the ones that found in the Unleashed firmware was this trivial Stack Overflow, but it unfortunately wasn't present in the upstream firmware. It was a bug in the EMV implementation, which is what credit cards use. And SIM cards and all of that. And after chatting with the agent for a bit about the details, I decided to move forward with building an exploit for this. The vulnerability is a classic user-controlled length men copy with no validation. So the parser reads the length from the user's input, doesn't verify the size, and then copies the user's data to the destination. I got to work building an exploit using my Proxmark as the delivery mechanism. And it was actually pretty quick. I wouldn't say it was a one-shot, but Claude managed to get this done very, very quickly from finding it to getting a working proof of concept, and then going from a working proof of concept to something that had attacker-chosen payloads in it that I could actually do some stuff. So this is a video showing the actual exploit. And I'll start it in a second. And this is the first time I landed actually choosing a reliable location where I could demonstrate control of PC. And what I did is I called the reset vector, just causing the flipper to reboot. You can kind of sort of see it, I guess. So this is just setting it up to read the EMV tag, and then I'm putting it next to the Proxmark, which is going to transmit the actual exploit. And so it resets. And so that's PC control right there, calling the reset vector. And so here's another screenshot or picture demonstrating that I can actually run my own ROP chain. So I was able to write out text to the flash and then crash it and then get it to load that text in there. So this text obviously isn't in the firmware. It's something that I wrote. So yeah, if you want the exploit, it's here. It's on GitHub. This isn't patched. They did release a new version of the Unleashed firmware, and it is not fixed, but the addresses for all the gadgets for the ROP chain have changed. So if someone wants to fix them, come show it to me, and I will have a Proxmark for you. I only have one, so whoever does it first can have it. This was originally done against the Unleashed, I think, 86 firmware. I think they're on 89 right now. So, but I did check. The vulnerabilities are still there. It is not fixed. I also haven't reported it, for what it's worth. After this time, I spent maybe a couple more weeks triaging and trying to land other vulnerabilities. There was a heap write that I had found that existed across both firmwares, but I wasn't able to get working. I ran into a number of issues during this and had a few observations. The first is that hallucinations are absolutely still a problem, as you can see at the bottom there. I ran into a number of cases where the agent just made up allocation sizes and ran with them, only later finding out they were completely breaking assumptions about like the heap alignment and how things were set up. As the agent went longer and longer without success, it often hit more and more roadblocks. It often wanted to give up without good reason, and I was just like, nah, just keep going. You got this. It was less convinced than I was. I ran into a number of bugs with the Proxmark firmware as well as GDB. I ended up upstreaming the fixes to Proxmark, which is great. Those are fixed now. GDB would just like crash. I don't know why. Apparently, its handling of like the remote debug protocol stuff is like not so hot, especially when you're using like a J-Link. So that was not pleasant. And the agent performed really poorly when the tools weren't reliable. And like this would happen for a human too. But like as a human, like I'm aware that it's the tools that are breaking. The agent isn't always aware of that, and so like it would be like, oh, that didn't work. Like I'm gonna not retry that, not understanding that it was like, no, the tool just failed. Like I should give that another shot. And finally, like the agent just wasn't good at understanding like viability of a particular bug. It would suggest bugs that were unrealistic to exploit or required primitives it didn't have. Especially if I looked at other stuff outside of this. It just doesn't have a good sense of like actual like real world like viability and usefulness of specific primitives all the time. So at this point, I've learned a lot and have a much better idea about how to work with these tools. I left off. Sorry, what did I say there? So where I left off before is that I had gotten through like a handful of layers of encryption and encoding, and I was trying to get the actual byte still of the bytecode. And I didn't know that I could trust the results that I had gotten because it kind of got stuck and was moving in a direction that like I didn't really understand like why it was stuck. I just knew that it wasn't moving forward. And so I basically had it take all the docs and like revalidate everything step by step, going through and making sure that like it proved that every step it was doing was accurate and what was coming out of it was what was expected. And at this point, Opus 4.7 had been released, so we've got like 1 million token context windows now, and I'm on the max 20 plan, which I've gotten nowhere close to exhausting. So I'm just like, fuck it, let's use Opus. Yeah. Were you asking a question or? Oh. Let's just use Opus for everything. So I have Claude do this, and I'm using a subagent. Oh, sorry. So the first thing I do is I have it convert all my docs into this wiki. Because like the docs had been like just exploding and hard to read and hard to follow. I was like, I want something that I can like go through easier. So I ended up building a subagent to do this. I had done it during the Flipper project, and it ended up working like pretty well. The one thing I still haven't gotten it to do is like it is so wordy, and I cannot get it to be concise like ever. And it will just like figure out like, oh, like I was wrong here. Let me correct that. But it will just have like string of correction after correction after correction, and it makes it so hard to follow along. And so like I'm still trying to like break it from doing that, and I haven't gotten that working. But after the new wiki was set up, it was time to validate the work. On the Flipper project, I let Claude use objdump almost exclusively for disassembly, and that worked surprisingly well. I'm guessing it helped that I had source code to go along with the firmware, and it was not stripped, but that wasn't the case with IonCube. This was a stripped binary with no source code, and so Claude was able to use objdump, but it was really slow, and it was blowing through my context window really quickly, and the agent took like 2,500 turns using about 385 million tokens over the course of about 18 hours. And this wasn't like running in a loop. It was like I was still prompting it. But like, yeah, it was a lot. So seeing it going poorly, I had started working on a solution in parallel to fix the original issues I had with Binary Ninja. One was being able to swap between files easily, and two was not needing to run like the full UI with it. So I ended up building a headless client that had a very similar interface to the bn.py that I had been using originally. I went back and forth about whether it should be like an MCP server, but I ended up going with a gRPC-based solution where you basically have like a headless Binja that has a gRPC server on it. And the reason I did that was that I wanted to have additional functionality that wasn't part of Binary Ninja. And like this has worked really well, and I like it. I think I'll probably end up changing it in the future as I go forward and having like a hybrid approach, because as I've added more features, like the command line interface has just kind of like grown to like an unreasonable amount. And like the LLM probably doesn't care about that, but like as a human that occasionally uses it, like it's not really pleasant having like 100 different subcommands that you have to sift through. So that's probably where I'll go in the future with it. Something I noticed was that the agent still kept opting for this like Python eval escape hatch all the time, and it was really token inefficient. And so one useful thing that I ended up doing was like in all of my prompts, just like, hey, if you see places where you're working around like limitations of the tool, like document that. And so I created this really good feedback loop of having the LLM tell me like why it was using the Python eval and not like doing something else, getting feature ideas like for the tool, and then having Claude implement those in the background, and then just like swapping out the server and client when it was done. And that ended up really helping. It helped get token usage down. It helped get speed up because it was more efficient with tokens. And like, I'll probably use this going forward. It ended up being like a really, really solid approach. Outside of these improvements, there was one really big change that I saw this time around, and that was the agent's like willingness and ability to leverage dynamic analysis. One of the things that shocked me immediately was it reached for Unicorn, which if you've never heard of Unicorn, it's a emulation framework for emulating machine code. And it used that to verify the PRNG implementations that it had re-implemented in Python. And so finally, we were at the point where we were verifying that like the implementations were correct and it wasn't a bug in those implementations. Later on, it even wanted to use GDB to inspect the specific constants, branching paths, and bytecode in the PHP interpreter once it had been loaded. And I had expected it to like give me some GDB commands like I did on the Flipper work, but it was just like driving GDB around, like, and it was like pretty good at it. Like it was shockingly good, especially when it wasn't crashing on me. And so this was a huge step forward from trying to get the agent to use C types originally. And I'm not sure if there's those improvements to the model or the harness or just luck from non-determinism, or maybe me being less prescriptive about the approach with like trying to use C types. But it really was like making progress again. Ultimately, after many more missteps, incorrect assumptions, and grinding with the agent, I got to disassembly. And from here, I was able to expand the corpus, identify bugs, gaps, and get them fixed while moving on to a full decompiler. So this is like PHP bytecode being disassembled. Going into this, I thought reverse engineering the file format and getting to disassembly would be the easy part, but I was wrong. Going from I can read opcodes to something that looks like PHP took like about a day. Like, I was shocked how fast that happened. To get to a fully functional decompiler that was effectively production ready, that took about a week. And it was all kind of like linear incremental improvements on top of that like initial sort of like work from that day. In hindsight, I think this kind of makes sense. The steps for building a decompiler are generally pretty well known and understood, and it's likely in the training data that the model has. From disassembly to recreate the control flow, so you basically go from disassembly to recreating the control flow graph. You reconstruct high-level semantics, and then you improve the output until it looks like good code effectively. So what do the economics of this look like? I'd estimate I spent about 3 to 4 weeks on and off working on this. About 1 week of that was the first session, and the other 2 to 3 weeks the second. I unfortunately don't have session logs from the first set of sessions. But I took the pricing data from Anthropic and I built a calculator based on their API pricing and the session logs that I did have. And so I want to be clear, I didn't use API pricing. This was like using like a monthly plan. But if I was doing API pricing, like through like a headless sort of like autonomous agent, this would have cost about $1,800 to do this. And that's like with no optimization. Like I could have, if I knew what I was doing going into this, I probably could have done a lot better. And I was also using the most expensive model. So I think it could be done like a lot cheaper. So what does this mean? The reality is that these types of protection schemes have never been particularly effective. There's always been a trade-off between time and value. How much can you delay someone from getting access to this? Because like at the end of the day, that's what you're trying to really do. Is like you're trying to hold off enough so that people don't spend the time to do this work. We've seen copy protection and obfuscation software virtually always defeated. Even for IonCube itself, they were paid like public services you could give money to. Thanks, DG. And the reality is these tools are probably going to get much weaker. Like copy protection tools are probably going to be much weaker because of the availability of these types of tools. It's likely easier for someone with much less skill than it has been before to break these in a faster time frame for a relatively small amount of money. I want to wrap this all up talking about what I think this all means for the future of security and vulnerability research. The reality is that none of us know. There's a lot of unanswered questions about how much more these tools will continue to improve and over what timeline, how expensive they'll be, what breakthroughs there still are to discover. But this is how I'm thinking about all of this. There's a couple metrics that are often used to discuss software bugs. You have density and depth. Density refers to the average quantity of bugs, generally like per line of code, while depth refers to the complexity of finding the bug. So shallow bugs are easy to find, while deep bugs are usually more subtle and require more effort. On average, density has always been high, and there has been many shallow bugs to find. The reason there isn't a constant flood of bugs all the time is because there's generally this balance of skill, level of effort, and return on investment for doing that work to find bugs in a particular target with a certain density and like bugs available at a particular depth. And so the introduction of agents capable of doing this has lowered the skill and level of effort required, which likely is shifting that balance a little bit. And this isn't the first time this has happened. When AFL was released, we saw a flood of vulnerabilities that got discovered as it got easier to do and required less skill and was easier to scale. And this found both a lot of shallow and deep bugs across that spectrum, and like drove the density of bugs down for software that was highly scrutinized. But it didn't remove all vulnerabilities. Eventually, for heavily reviewed targets, it became harder for AFL to find bugs as the classes of vulnerabilities it was good at finding bugs were found and fixed faster than new ones were being introduced. And this likely is going to happen again at some point in the future. What may be different this time is that due to the push toward generating more code with agents, we may see new vulnerabilities introduced faster or enough new interesting targets become available at the same average of previous density and depth. And it's not clear that the code generated from these tools produces code with lower density or deeper bugs. It's just that maybe a lot more will exist. Like, software's always been pretty bad. People just haven't been looking. And I think we need to look at vulnerability discovery capability as a funnel. At the top is simply finding a vulnerability in any target. And at the bottom is finding a useful, exploitable vulnerability in a specific target. As you go down the funnel, it gets more difficult, more expensive, and requires more skill. Generally. It's not like always the case. But a lot of these companies and researchers are focusing on right now is somewhere near the top of this. They're like doing these like big surveys across like a lot of things, and they're just like looking for something they can talk about. At least most of them. It's a new capability that's being shown, and it's impressive, but what will eventually matter, once all the hype and unlimited money is gone, is like, what is the value that's being created by these tools? There was a recent paper called Exploit Bench comparing different capabilities through the pipeline of discovery, verification, and proof of concept across various models across a set of like V8 vulnerabilities across like a 10-year period or something like that, maybe shorter. And I take these benchmarks with a grain of salt because I think that like these could easily be gamed. But I think it's an interesting just like thing to look at. And so you see Mythos preview at the top here with GPT-5.5 following below. And Mythos is about 68% better, like end-to-end building an exploit chain for vulnerabilities, like for this sample set that it did. But it's also 12 times more expensive. The major difference here is that Mythos is able to get like full code exec in many more situations, but GPT-5.5 and the majority can demonstrate the primitive, which as an AppSec team, like, is generally what you care about, is verifying that the bug is there, it's real, it's reachable, and it does the thing that is being talked about. If you're a threat actor needing a 0-day, like, maybe you actually do care about this. And the cost makes sense. Like, if it costs you $30,000 to make a bug, to make an exploit, but you're going to make $100,000, $500,000, $1 million from whatever you're doing with it, or you're working for someone that has some other mission that's not money, like that's a pretty low investment cost considering like what bugs cost to buy. But for an AppSec team, maybe it doesn't. And so like a lot of this was being done with the assumption that token cost will continue to go down. The models will get better, and we'll see continued improvement. We don't know if any of that's going to happen. People think it is, but we don't know. Finding and proving bugs is also only a really small part of the life cycle. And so, like, once you've found the bug, you still need to triage it. You need to fix the bug. You need to get it rolled out. You need to make sure everything's good. And some of that is much harder to do, and know that you're not introducing like new issues and new problems. And so how many various how many successful vulnerability management programs do you know? There's not so many. Like, it's a really hard problem. And so I've gone back and forth on how much I think harnesses actually matter and how much variation and like what that means for the process. There's been a bunch of people talking about like building these complex pipelines and harnesses and getting like big improvements to the harnesses. I did everything that I talked about with a pretty dumb, very blunt tool, getting like really good results fairly cheaply. I do think that harness improvements will help optimization, which will in turn hopefully make things cheaper and maybe faster and a little better. But I also think the value will plateau. And the question we need to figure out is like how much complexity is the right amount for these pipelines? Like, when do you get diminishing returns from a level of investment building these more complex systems? And so I want to leave you with one last observation about Mythos for everyone who's scared about what it means and the future of the industry. So curl is one of the most heavily reviewed C code bases like in the world. And it's known for being incredibly high quality, low bugs. I mean, like, this is like a well-regarded code base across the industry. Through Project Glasswing, which is Anthropic's like program to like find bugs and like really high value sort of things, 5 bugs were discovered and reported being found with Mythos, of which 1 ended up being a true security vulnerability. Just 2 weeks later, Daniel, the author and maintainer of curl, he posted on Mastodon saying that there had been 10 CVEs reserved in like the most recent release, and none of them had been discovered by Mythos, other than like there were 11 technically, but like 10 new ones. Only 1 had been discovered by Mythos. And so Mythos is this tool that's being touted as like this incredible thing, but like there's still so much out there that's being found by others, and like there's so much more than just that. Thank you. I think we have a few minutes for questions if anyone has one. Otherwise, I will turn it over. Yes.
Do you know if the other 10 CVEs for curl were discovered with AI?
The question was, do I know if the other 10 curl CVs were discovered with AI? I don't know the answer to that question. I kind of remember him saying something about that they were, but I'm not 100% sure. If you go read the Mastodon post, it might say. Yes?
Not up to date on all the terms of use. If you find a valuable exploit using Mythos, does that Anthropic not also own that exploit? If you know the review, they know that.
I'm not a lawyer. I can't answer that question for you. The thing is like, bugs that people, like, I don't think ownership matters as much. Like, bugs that other people know about aren't that useful if they're getting fixed. If they're not getting fixed, like no one wants to pay for a bug that other people know about. It's why exclusivity exists. Anyone else? Cool. Thank you.